So we're going to derive the formula of the double angle to get sine squared isolated, to be able to integrate this without that trigonometric function being squared. So start by picking one of these double angle formulas. Cosine 2 theta equals cosine squared theta minus sine squared theta. So as I said, we want to find an expression for sine squared, and we don't want to have cosine squared, so find a way to replace this cosine squared with a different expression, and that will be right up there in the Pythagorean identities. So if we want cosine squared, we're going to isolate it like subtracting sine squared theta from both sides, and we have that new expression. So we rewrite this whole double angle formula as, instead of cosine squared, the expression we have there, 1 minus sine squared theta. And then we simplify the right hand side of this equation, minus 2 lots of sine squared theta. Our focus still is to isolate sine squared. Because it's a negative term, probably I preferred to add 2 sine squared to both sides. So we add it on the left hand side and on the right hand side, and maybe at the same time we subtract cosine theta from both sides, just like we were doing. Having that one on that side is more convenient, and that one on this side. So what happens now? We are almost ready to isolate sine squared theta, so all we need to do is divide both sides by 2. So this big fraction could be broken down into 2 separate fractions, like half take away cosine 2 theta over 2, or we could actually pull that half that is there for the whole expression to the front, use brackets, and keep the 1 minus cosine 2 theta in brackets. So this will facilitate the integration of the expression of cosine 2 theta in this case.